Hi everybody. Today we're going to continue talking about patterns of evolution. We've already talked about adaptive radiation, where you have one species evolves to become many different species over the course of time. The opposite pattern would be convergent evolution. And this is when you have different unrelated species evolving to become more similar because they live in similar environments. Take sharks and dolphins for example. You may look at a shark and look at a dolphin and realize that they have a lot of similarities. They both have streamlined bodies, and they both have fins, and they have the same habitat. However, you'd be wrong in saying that they share a recent common ancestor. You see, these two organisms aren't very closely related to it at all. Sharks are fish, right? And their relatives are that of fish, right? The dolphins are mammals, right? Therefore, dolphins are more closely related to humans through evolution than they are to sharks. However, they both evolve similar characteristics completely separately from one another just because those characteristics both allow them to be successful in the ocean environment that they share. The next pattern of evolution I want to talk about is coevolution. And coevolution is when you have two species that are so closely related to each other that when one species changes due to evolution, the other species has to change in response. Take, for example, cheetahs. Everybody knows that cheetahs are the fastest animal on land. And what people don't often know is that gazelles are usually the second fastest animal on land. The thing that you need to know about cheetahs and gazelles is that cheetahs almost exclusively hunt and eat gazelles. Now, do you think it's a coincidence that the fastest animal on land, the cheetah, hunts the second fastest animal on land, the gazelle? No. Right? You see, if you are born to a cheetah and you happen to be a slow cheetah, you're going to die. Right? Because you're not going to be able to catch any of the gazelle and you're going to starve to death. Therefore, cheetahs are evolving to become faster and faster and faster. However, if you're born a gazelle and you happen to be a slow gazelle, you're going to die because you're going to get eaten by a cheetah. So because the cheetahs are getting faster, the gazelles have to get faster. And because the gazelles get faster, the cheetahs get faster. Right? It's kind of like this cycle of speed. The next two patterns I want to talk about are related as well. The first is punctuated equilibrium. Right? And punctuated equilibrium says how species change over long periods of time, right? And what you see is that evolution, according to punctuated equilibrium, is not this slow and steady rate, right? What punctuated equilibrium says is that species stay the same for long periods of time, right? Look at these shells here, right? So you have blue shells, blue shells, blue shells, and all of a sudden you have this huge shift, right? This rapid evolution, and then you have green shells, right? And it stays green shells for a long period of time, and then this huge shift over to yellow shells. Right? So you have long periods of time where organisms stay the same, and then you have these short, rapid periods of evolution. Now, what could cause these periods of rapid evolution? Well, one event could be a mass extinction. Right? And we've seen this when we look back in the fossil record. Right? We have dinosaurs, and then boom, a mass extinction. And then you have this rapid evolution of new mammals start forming, right? After the dinosaurs went extinct. The other thing that can cause this rapid evolution would be isolation, right? So you have one population all of a sudden gets split apart, right? They end up on opposite sides of the Grand Canyon, or of a river, or something like that. And now these two species, these two populations will evolve independently of one another. The final pattern of evolution I want to talk about today is gradualism. And gradualism is kind of the opposite of punctuated equilibrium. Right? According to gradualism, you don't have these rapid shifts in evolution periods of time where things are pretty much staying the same, right? You have this blue shell and it slowly kind of fades into, this purple shell up here or this green shell over here, right? So you have evolution at this slow and steady pace. Alright, now what we see when you go back and look in a fossil record is not just gradualism or just punctuated equilibrium. You have times where species or populations tend to follow this gradualism pattern of evolution, and then you have other times and other populations that follow the punctuated equilibrium pattern of evolution. Alright guys, that's it for today's lesson. Thank you.